So I've shown you that we can build a power supply that gives us particular design voltages using a voltage divider, say 0, 1, 2 volts in our case, and activate each output through a single wire, the green one here, by pushing either of 3 push buttons. And because the Thevenin resistances are all 10K or less, into a 1 million ohm resistor, the drop is less than 1% from our design goal. And if we use a 10 kilo ohm resistor, however, which is closer in range to the Thevenin resistance, we see significant voltage drops when we attach it across that sort of load. So now I want to consider actually solving the problem completely of the voltage drop by using a op-amp. The circuits will look like this. There you go. Clarity. The op-amp, which is this triangular shape, just as shown in the lectures, takes the input and makes it equal to the output, or the output makes it equal to the input in this configuration, which has a loopback with no resistance feedback, and that's the follower configuration. The Thevenin resistance, however, will drop to almost 0, meaning that this output can drive just about any load we want. Here is the op-amp we are going to use. It comes from the extras IC box. This is the TLO81 op-amp. This is a really great op-amp for use, especially in audio applications. It is in an 8-pin package. Notice the dot in the upper left-hand corner I've lined up with the pin out. So this dot indicates pin 1 in 8 pins, and you can see the schematic diagram here is superimposed on the pin out, so you can see the 2 inputs. The -1 is called the inverting and the plus the non-inverting input, and then the output goes out here over pin 6, so inputs on 2 and 3, output on 6. It is an active device. Unlike a resistor or capacitor, it requires power, so there's a ground and power supply VCC voltage coming in. Pin 8 is not connected, and we will not be using the balancer offset capabilities in this experiment, which are pins 4 and 5, 1 and 5, so they'll be left unconnected as well. And this output, of course, is what we can connect to our load and measure, and we hope to not change when we apply different loads.